Imagine this. Your SIEM dashboard is silent. No critical alert, no malware detection, no ransomware warning, no firewall block. Everything looks normal. But inside the network, an attacker is already active. They are not creating noise. They are not triggering thousands of failed logins. They are not dropping obvious malware. They are moving carefully. First, they collect information. Then they prepare infrastructure. Then they send a phishing email. Then they get initial access. Then they execute commands. Then they maintain persistence. Then they try to increase privileges. Then they hide their activity. Then they weaken your security visibility. Then they steal credentials. Then they perform discovery. Then they move laterally. Then they collect sensitive data. Then they connect to command and control. Then they exfiltrate data. And finally, they create impact. This is not random activity. This is attacker behavior. And this behavior is exactly what MITRE ATT&CK helps us understand. In today's session, we are going to learn how SOC Analysts can use MITRE ATT&CK for threat hunting. Because real threat hunting is about hunting attacker behavior. Namaste everyone. My name is Vikram Saini and you are watching VikCyberWatch. Welcome to session 5 of our threat hunting course. In the previous sessions, we learned what threat hunting is and how alert monitoring is different from threat hunting. We also learned how to think like a threat hunter and how to create a hunting hypothesis. Now we will connect all of that with one of the most important frameworks in cybersecurity, MITRE ATT&CK. But before we start, one important update. MITRE ATT&CK has changed. Earlier, we had 14 tactics, but in the updated version, MITRE has split defense evasion into 2 tactics, stealth and defense impairment. Stealth helps attackers blend in, while defense impairment degrades security controls. Hiding and breaking are not the same thing. So today's session is fully updated. Let us start simple. MITRE ATT&CK is a knowledge base of attacker behavior. It helps us understand how real attackers operate. It does not only tell us which malware was used, it tells us what the attacker was trying to do. For example, were they trying to get in? That is initial access. Was the attacker trying to run commands? That is execution. Was the attacker trying to stay inside the system? That is persistence. Was the attacker trying to steal passwords? That is credential access. Trying to understand the environment? That is discovery. Moving machine to machine, that is lateral movement. This is why MITRE ATT&CK is powerful. It gives us a map. And as threat hunters, we use that map to search for hidden activity. A beginner SOC analyst asks, which alert came? But a threat hunter asks, which attacker behavior could be happening silently? That is the difference. Before we use MITRE for threat hunting, we need to understand 4 words. Tactic, technique, sub-technique, procedure. Let us understand this in simple language. A tactic is the attacker's goal. It answers the question, why is the attacker doing this? For example, the attacker wants to get inside the network. That is initial access. The attacker wants to steal credentials. That is credential access. The attacker wants to move to another system, that is lateral movement. Now, a technique explains how the attacker achieves that goal. For initial access, the attacker may use phishing. For credential access, they may dump LSAS's memory. For lateral movement, the attacker may use RDP, SMB, WinRM, WMI, or remote services. So remember this, tactic means why, technique means how. A sub-technique gives more specific detail. For example, phishing is a technique. Spear phishing attachment is a sub-technique. Valid accounts is a technique. Domain accounts is a sub-technique. A procedure is how a real attacker uses that technique in the real world. For example, one attacker may use PowerShell with encoded commands. Another may use a signed Windows binary. The technique may be similar, but the procedure can be different. For threat hunting, this is very important because we are not only hunting tools, we are hunting behavior. Many beginner analysts start threat hunting by searching only indicators. They search for IP addresses, domains, hashes, file names, URLs. These indicators are useful, But indicators can change quickly. An attacker can change an IP, an attacker can change a domain, an attacker can change a file hash, an attacker can rename a file. But attacker behavior is harder to change. If an attacker wants to steal credentials, they still need some method to access credentials. If an attacker wants lateral movement, they still need some method to move. If an attacker wants persistence, they still need some way to maintain access. That is why behavior-based hunting is stronger than only IOC-based hunting. MITRE ATT&CK helps us move from "is this IP malicious?" to "is this user behaving like a compromised account?" It helps us move from "is this file hash bad?" to "why was this file created, executed, and deleted within seconds?" It helps us move from "did an alert fire?" to "which attacker technique could be happening silently?" This is the real value of MITRE-based threat hunting. Alerts may show incidents, but behavior shows attackers. In the next part, we will look at the 15 updated tactics. Now let us quickly understand the updated enterprise tactics. MITRE's current enterprise tactics list includes 15 tactics: reconnaissance, resource development, initial access, execution, persistence, privilege escalation, stealth, defense impairment, credential access, discovery, lateral movement, collection, command and control, exfiltration, and impact. Do not worry, you do not need to memorize everything on day one. But as a SOC analyst, you should understand the flow. An attacker may first gather information, then prepare resources, then enter the environment, then execute commands, then maintain access, then increase privilege, then hide activity, then weaken defenses, then steal credentials, then discover the environment, then move laterally, then collect data, then communicate with external infrastructure, then exfiltrate data, then create impact. This is the attacker lifecycle. And MITRE helps us break this lifecycle into huntable behaviors. Now we will explain each tactic in simple SOC language. 1. Reconnaissance. Reconnaissance means the attacker is gathering information. This may happen before the actual attack. The attacker may search company websites, employee names, email formats, technologies used, public IP ranges, exposed services, GitHub repositories, leaked credentials, LinkedIn profiles. From a SOC perspective, some reconnaissance may not appear inside internal logs because it can happen outside the company network. But you can still hunt for some signs. For example, repeated scanning against public-facing servers, suspicious probing of web applications, unusual contact form submissions, credential stuffing attempts, brand impersonation attempts, lookalike domains. 2. Resource development. Resource development means the attacker is preparing resources for the attack. They may register domains, create phishing pages, set up VPS servers, create fake profiles, prepare malware, create infrastructure for command and control. From a SOC perspective, this is often supported by threat intelligence. You can look for newly registered domains similar to your brand, domains that look like your company, infrastructure communicating with your users, external IPs linked to suspicious activity. 3. Initial access. Initial access means the attacker is trying to get into your environment. Common methods include phishing, exploiting public-facing applications, using valid accounts, drive-by compromise, supply chain compromise. For hunting, ask, are there suspicious successful logins? Are there new VPN logins from unusual countries? Are there emails with suspicious attachments? Are there exploitation attempts against public servers? Are there new cloud sessions from unknown devices? Initial access is one of the most important areas for SOC teams because if you can catch the attacker here, you can stop the attack early. In the next part, we cover execution, persistence, and privilege escalation. Now we come to the next phase of the attacker lifecycle: execution, persistence, and privilege escalation. Let's break down how attackers maintain and expand their control. 4. Execution. Execution means the attacker is trying to run code or commands. This is where their malicious payloads come to life. Examples include PowerShell, command prompt, scripts, macros, remote execution, malicious binaries. For hunting, ask, is PowerShell being launched by Office? Is CMD running from an unusual parent process? Is a script running from a temporary folder? Is a binary executing from downloads or app data? Is a command connecting to the internet after execution? Context is vital. Useful logs include Windows Event ID 4688, Sysmon Event ID 1, PowerShell Event ID 4104, and EDR process telemetry. 5. Persistence. Persistence means the attacker wants to maintain access, making sure they stay inside even after a reboot or a password change. They may create scheduled tasks, new services, registry run keys, starter folder entries, new accounts, web shells, hunting questions. Were new scheduled tasks created? Were new services installed? Was a new local admin account created? Were registry autorun keys modified? Was a suspicious file added to a web server directory? Scheduled task or job is a very common technique for recurring execution of malicious code. 6. Privilege escalation. Privilege escalation means the attacker wants higher permissions. They have the foot in the door, now they want the master keys. They may abuse misconfigured services, token impersonation, weak permissions, UAAC bypass, or vulnerable software. Hunting questions. Did a normal user suddenly perform admin activity? Was a user added to a privileged group? Did a process run with elevated privileges unexpectedly? Was there suspicious service modification? Was there token abuse? Privilege escalation is vital because attackers want more control after initial access. Next, we tackle two of the most critical and newly updated tactics, stealth and defense impairment. See you in the next part. Now we come to the important updated part. Earlier, many analysts used the term defense evasion broadly. But in the updated MITRE structure, we need to clearly understand stealth and defense impairment. 7. Stealth. Stealth means the attacker is trying to blend in and reduce detection. They are not necessarily breaking your security tools, they are trying to look normal. Examples include using legitimate tools, renaming malware to look normal, using encoded or obfuscated commands, and using normal admin utilities. Hunting questions. Is a normal tool behaving abnormally? Is a binary renamed to look like a Windows process? Is an admin tool used by a non-admin user? Is command line obfuscation visible? 8. Defense impairment. This is different. Here, the attacker is trying to weaken, disable, or damage your security visibility and controls to reduce your ability to detect or respond. Examples include disabling antivirus, stopping EDR services, clearing event logs, disabling firewalls, changing audit policy, or deleting backups. Hunting questions. Was Windows Defender disabled? Was an EDR service stopped? Were logs cleared? Was audit policy changed? Was Sysmon stopped? Was a firewall disabled? Was telemetry suddenly missing from a critical host? This distinction is very important. Stealth means hiding. Defense impairment means blinding the defender. A threat hunter must hunt both. Next, we move to the tactics that keep every SOC analyst awake at night. Credential access, discovery, and lateral movement. I'll see you in the next part. Credential access, discovery, and lateral movement. These are the tactics that keep every SOC analyst awake at night. Let's break down how attackers expand their control inside your network. 9. Credential access. Credential access means the attacker wants your passwords, hashes, tokens, cookies, or keys. This is their ticket to total environment control. Common methods include LSASS dumping, Kerber roasting, password spraying, browser credential theft, credential files, and key logging. For hunting, ask, are suspicious processes accessing LSASS? Is procdump being used on a workstation? Are there failed logins followed by successful logins? Are browser credential files being accessed? Useful logs include Windows security logs, Sysmon event ID 10, EDR telemetry, authentication logs, and Kerberos logs. 10. Discovery. Discovery means the attacker wants to understand the environment. They are exploring your network like a digital map, looking for their next target. They may run commands like whoami, hostname, ipconfig, netuser, netgroup, netview, nltest, and dsquery, or even bloodhound collectors. Hunting questions. Is a normal user running domain discovery commands? Is one endpoint querying many systems? Is PowerShell enumerating AD objects? Are discovery commands running after a suspicious login? Discovery is often missed because many commands look harmless alone, but when combined, they reveal clear attacker intent. 11. Lateral movement. Lateral movement means the attacker is moving from one system to another. This is how they spread across your organization. Methods include RDP, SMB, WinRM, WMI, PSExec, remote services, and SSH. Each one is a path for the attacker to move deeper. Hunting questions. Is one user logging into many hosts? Is there remote service creation? Is there admin share access? Is a user connecting to systems they never used before? Useful logs include Windows Event ID 4624, 7045, and 5140. Sysmon network logs, EDR telemetry, and firewall logs. Lateral movement is vital because it shows attacker expansion. Next, we cover the endgame: collection, command and control, exfiltration, and impact. I'll see you in the next part. Now we come to the final stages of the attacker lifecycle: collection, command and control, exfiltration, and impact. This is where the attacker realizes their ultimate goal. 12. Collection. Collection means the attacker is gathering data before stealing it. They are rounding up your most sensitive information into one place. They may collect documents, emails, databases, screenshots, clipboard data, browser data, and other sensitive files. For hunting, ask, is there bulk file access? Are many files being copied to one folder? Is data being compressed? Are sensitive shares being accessed unusually? 13. Command and control. Command and control means the compromised system is communicating with attacker infrastructure. This is how the attacker sends instructions to their malware. This may happen over HTTP, HTTPS, DNS, cloud services, remote access tools, or even custom protocols. It's the umbilical cord of the attack. Hunting questions. Is there periodic beaconing? Are endpoints connecting to rare domains? Are there suspicious DNS patterns? Are there unusual user agent strings? 14. Exfiltration. Exfiltration means the attacker is stealing data from the environment. This is the moment they take what they came for. Methods include cloud upload, HTTP upload, FTP, email forwarding, and even DNS tunneling. They are looking for any way to sneak data past your perimeter. Hunting questions. Is there unusual outbound data volume? Are archive files leaving the network? Is sensitive data being uploaded to personal cloud storage? 15. Impact. Impact means the attacker is trying to disrupt, destroy, encrypt, or manipulate systems. This is the loud part of the attack. Examples include ransomware encryption, data destruction, account lockout, service shutdown, website defacement, or even backup deletion. Hunting questions. Are many files modified quickly? Are backups deleted? Are services stopped across many systems? Is there mass encryption behavior? Impact is usually when the attack becomes visible, but threat hunting should ideally catch the attacker before this stage. Next, we convert all this into a hunting hypothesis.